Hello. So today is Wednesday, October the 12th. Wednesday, October the 12th. Today we're looking at day four, optimizing perimeter and area. Okay. So again, you can find everything underneath this link. But seeing as you're watching this video, I'm assuming you had no issues finding what you needed to find. So our job today is to determine the best solutions while adhering to given restraints. In other words, we're looking to optimize perimeter and area, so we want to, let's say, maximize the area to find, let's say, a maximum deck size, or we might want to find minimum perimeter for a fixed area. Want to minimize the perimeter for a certain area. An example of this could be using the fewest amount of fencing available to fence in a certain area. And in this case, maximizing the area is getting as much area as possible given a certain perimeter. Okay, so let's take a look at this example, a rectangle. So if you look at a rectangle, look at the first example, we can see that the length is 15 and the width is 5. So if I were to draw a sketch of that, so 15 meters by 5 meters. Okay, now looking at this, you can tell we're only using 20 meters of fencing or whatever we're working with on the one side. In fact, you can see that all these conditions, they add up to 20, right? 12 and 8 add up to 20, length and width. 10 and 10 add up to 20. 18 and 2 add up to 20. 9 and 11 add up to 20. Okay? What would be the perimeter of all these rectangles? Well, the first one's already done for you. 15 plus 5 is 20, times 2 is 40. That's our perimeter, the distance around, right? 15 plus 5 is 20, and there's two sides to it, or four sides, sorry. So we're going to do the same thing here and see what the perimeter is. 2 times 12 plus 8. Well, this is also going to give me 40, because 12 plus 8 is 20, times 2 is 40. Same thing here, 2, 10 plus 10, this will also give me 40. 2 times 18 plus 2, this will also give me 40. And then last but not least, 2, 9 plus 11, this will give me 40. So you can see here that all these rectangles from A to E have the same perimeter of 40 meters. Now let's see what the area is like. So area, just as a reminder, of any rectangle is length times width. So what's the area of this one? 12 times 8. This gives me 96 meters squared. Okay, let's look at this next one. 10 times 10. That gives me 100 meters squared. Let's look at this next one. 18 times 2, giving me 36. Let's look at this last one. 9 times 11 equals 99. Now, let's look at this table for a second, and what do we notice? Well, the rectangles above have the same perimeter. Which one of these rectangles have the greatest area? It looks like rectangle C has the greatest area. So, what do we notice about rectangle C though? Well, rectangle C has the same length as it does the width, which we know this rectangle by another name. 10 by 10, we know this as a square. So, what's our conclusion? When enclosing four sides, the maximum rectangular area for a fixed perimeter is obtained by forming a square. Okay? So if your boss tells you you have 40 meters of fencing to work with, I want you to come up with the largest possible area. What you would do is you would form a square. You would form a square, four sides, 10 meters a side, and that would be the largest possible area. And there's no other combination that will give you an area that's more than 100 meters squared. So, let me scroll down a little bit. I'm going to jump right into a couple of these examples. So, find the dimensions, integer values, of the largest rectangular area that can be made given the following perimeters. Okay? So I'm given the fact that it's 48 meters of fencing. I know with a fixed perimeter the in order to get the largest rectangular area, I need to turn this into a square. So all I need to do then is 48 meters divided by 4, because there's 4 sides in a square slash rectangle, equals 12 meters per side. Okay, so calculate the area of each shape. So based on that, then I know that 12 plus 12 plus 12 plus 12 is 48 meters, and that this is a square, so this would be the largest possible area I could form with 48 meters of fencing. So then the area would be simply 12 times 12 equals to 144 meters squared. So with 48 meters of fencing, the largest possible area I can enclose is 144 meters squared. Okay, I'll let you, at this point you can pause the video and you can try B, C, and D using the exact same logic I just applied to example A. Okay, so assuming you have paused the video and that you have given those questions a try and finished them, we are now going to look at minimum perimeter for a fixed area. So now in this case, I'm telling you, hey, I want 200 meters squared, but I don't want to spend a whole lot of money on fencing, so I want you to find me the minimal amount of fencing possible to enclose 200 meters squared. So let's take a look here and see what happens. So rectangle A, 2 times 18 is the area, 36. So let's look at rectangle B. 3 times 12 is 36. 4 times 9 is also 36. 6 times 6 is also 36. 9 times 4 is also 36. So all these rectangles have the same area. Now let's look at the perimeter. So the perimeter, the distance on the outside, right, is just 2 times the length plus the width. So 3 plus 12. So 3 plus 12 is 15. 15 times 2 is 30. So this perimeter is 30. Let's take a look at the next one. 2 times 4 plus 9. Well, 4 plus 9 is 13. Times 2 is 26. 6 plus 6. So 2 is times 6 plus 6. 6 plus 6 is 12. Times 2 is 24. And then 9 plus 4. So 2 times 9 plus 4. 9, 13. So that's 26 as well. So which one has the least perimeter? It looks like it is that one, rectangle D. Well, what do we notice here? When enclosing 4 sides, the minimum perimeter for a given rectangular area is again obtained by forming a square. Okay, so let's take a look at this example. Find the dimensions of the rectangle that would provide the least perimeter if the area is 81 meters squared. So I know that if I'm told that I need an area of 81 meters squared, and I am told that I want to save the company some money, so I want this minimal amount of fencing as possible, I know the shape to make that happen would be a square. So the solution for this is the square provide the least perimeter. We know the area of this square is 81, which means one of the side of the squares is 9. How do I know that? Because the square root of 81 is 9. 9 times 9 is 81. Therefore, a 9 by 9 square will give the least perimeter. Okay, so let's try this example. So the boss comes along and tells you, hey, I want you to give me a fence in an area of 36 meters squared, but I want the fewest amount of fencing as possible. So what do? You take a look at that. You find the square root of 36, which is just 6. So you now know that 6, 6, 6, 6, this would be the fewest amount of fencing possible. Okay, therefore, a 6 by 6 square will give you the least perimeter of, what would the perimeter be? 6 plus 6 is 12, times 2 is 24 meters. Yeah. Therefore, a 6 by 6 square will give you the least perimeter of 24 meters. 6 plus 6 plus 6 plus 6 is 24. Okay? Now, if you're not sure what where to find the square root button, it's usually the bus shelter looking thing, like that, and you'll get 6. Okay? In some calculators, you might need to second function to find the square root sign. So again, at this point, I would suggest you pause the video to try some of these questions. Okay, so I'm assuming you have tried those questions, and now for the last concept, a maximum 3-sided area. So let's say you want to close in a chicken coop, and you're going to use a building as your third side. Okay, so when enclosing 3 sides, the maximum area for a given rectangular area is formed by enclosing a rectangle whose length is twice its width. So to find the maximum area given a certain amount of fencing, okay, in order to find that maximum area, whatever width you have here, so let's make up a number, let's say it's 10, the length should be double that. So if the width is 10, then the length should be 20, and so forth. Okay? So let's take a look at these examples. Your manager asks you to create a 3-sided rectangular area at the beach with a 100-meter rope that will have the greatest area. What are the dimensions? So we're going to assume that the third side is going to be water. So what are the dimensions? We want the greatest area. Well, we know that this whole perimeter is I'm not going to enclose the area that's on the water, of course. So since it's only a 3-sided shape, and I have a 100-meter rope to work with, right? Now I have 1 W there, 2 W's there, another W there. So I have 4 W's equals to a 100-meter rope. Okay, so what's 1 W then? Divide by 4, divide by 4. So 1 W would be 25 meters. Okay, so therefore, if this is 25, and what's 2 times 25? This would be 50. So therefore, a 25 by 50 rectangle with its 3 sides enclosed would give you the maximum area. Okay, so now let's try. I'm going to do this example here and then have you practice. So organizers of an outdoor music festival want to enclose a rectangular dining area against a large barn. So we want to form a fence here, here, and here. They have 80 meters of rope to use as fence, so 80 meters of rope. Determine the length and width of a fence that will provide the maximum dining area. Okay, so we know that we have 1 W here, 2 W here, 1 W here. I don't need this last side because if I did, then I would just form a square, right? So I know that 4 W's will give me 80 meters. So divide by 4, divide by 4. W is equal to 80 divided by 4, which is 20 meters. So therefore, that means if this is 20, then this would be double 20, giving me 40 meters. So therefore, a 20 meter by 40 meter dining area will provide a maximum area with 80 meters of rope. We're done. Okay, so at this point, you can practice these, I think, 5 questions, and then you're done for the day. Okay, have a good day. I'll see you tomorrow.